no, I have not taken a shower or brushed my hair yet today. So now that that's addressed. So first and foremost, if you have not seen the video that comment is attached to, you have to go watch that first. Otherwise, you'll have no idea what I'm talking about. I'm being completely serious. You go now. On a swing on the chandelier, from the chandelier. Oh, you're back. Hey. This is the part 2 video of the wizardly skills of Soluble. Yes, I said Soluble ACE2. And its side hustle of chauffeuring SARS-CoV-2. Its uncanny ability to meddle in the business of the immune system, mainly through preventing the formation of antibodies. So when we last left off, the other thing this article discussed is not only do the antibodies have difficulty in targeting it, it may impact our ability to form antibodies to begin with. So how does that happen?
First, we need to understand how antibodies are formed. Here we see a B cell. A B cell is one of our immune system cells. B cells also have their own specific receptors. But in this case, it's looking for things that do not belong within the body. So it uses its receptor to find and bind antigen. And in this case, the antigen is the spike protein of the SARS-CoV-2 virus. Now, after the specific receptor on the B cell attaches to that antigen, it then pulls in that antigen. Like how we saw it happen earlier, except for this time, it's looking for things that don't belong and need to be destroyed. After the antigen is pulled in and digested into little antigenic peptide fragments, it'll form little vesicles. These vesicles will either be antigenic peptide fragments or something called major histocompatibility 2 complex molecules, also known as MHC2. Vesicle fusion occurs next. So the MHC2 complex molecule vesicles will fuse with the antigenic peptide fragments vesicles. I tend to think of it as two schools coming together under one roof for a school dance. The MHC2 molecules, along with the antigen peptides, both grab a partner do-si-do. They bind together and are transported to the cell surface. So it's like they leave the dance together to the surface. Now, on the surface of the B cell, MHC2 kind of pulls a Patrick Swayze with the antigen. That MHC2 complex presents the antigen to a helper T cell, a CD4 T cell. Now, binding of the T cell receptor to antigen that's being presented on the B cell triggers the T cells to release interleukin-2 to the B cell, therefore activating the B cell. Those activated B cells proliferate into identical B cells in a process that's called clonal selection. And most of these cells differentiate into what's called plasma cells or effector B cells. And they are the ones that release antibodies. And all of these B cells would be making antibodies very specific to that initial antigen that was presented.
So why does that matter?
Because the frequency of B cells binding to that antigen may be greatly impacted if soluble ACE2 is cloaking it.
So you can see that it's pretty problematic all the way around. But anyway, I do hope that that was helpful. And let me know in the comments if you have any other questions.